Hello viewers, today I'm going to talk about skew lines. I'm going to talk about skew lines, how we can determine the shortest distance between skew lines in space. We are going to use graphical means to determine the clearance between skew lines. In this case, we are looking at the shortest possible distance between two lines that are suspended in space. We are talking about skew lines here. How do we define skew lines? Skew lines are non-parallel, non-intersecting lines in space. Any lines that are not parallel and do not intersect in space will obviously leave a gap between them. Those lines belong to different planes. We call them skew lines. Right, the most important thing to look at when you are dealing with skew lines is to select one line. You pick one line that you would want to reduce to a point. Remember, for you to reduce a line to a point, you need, first of all, to find its true length, its natural length. After getting its true length, you then project a view along its end. If you project a view along the end of a line, any straight line, the line reduces to a point. This is what we want to do. So we want to project an auxiliary view which will reduce one line to a dot or a point, and the other line will remain as a line. We want to end up with a situation where we have a point and a straight line. And for us to be able to determine the distance, shortest distance from a point to a straight line, we need to construct a perpendicular. That distance is measured along the perpendicular from a point to a straight line. This is what we want to do, and it will assist us in determining the shortest distance between any two skew lines in space. In this case, we are given two views in orthographic projection. As you can see, the top part is the front. This picture shows the front elevation of two lines in space. The lines are A, B, and C, D. And the XY is the reference line. This is our reference line. In this case, as seen from the elevation, this one is showing the horizontal plane. And as seen from the top, we are seeing what we call the plan of the same lines that are in space. A1, B1, C1, D1. These are the two lines that we are dealing with, which are in space. Right? I will have to choose or select one line to reduce to a point. In this case, I'm picking line CD on the plan. So what I need to do is to project an auxiliary view at 90 degrees to the line CD. So I'm going to project a view as taken at 90 degrees in this direction, making sure this is 90 degrees. So that auxiliary view is going to give us the true length of CD. So I will project lines at 90 degrees. These lines are going to be parallel, passing through C, passing through B, and another one passing through A. All these lines are projection lines. So the next thing I need to do is to create a new XY plane to replace the original XY plane is here. So we need a new XY plane, which is also taken at 90 degrees or perpendicular to the lines of projection. So I can place it at any position of convenience. This is taken at any position of convenience. I'm going to put my new XY, X1, Y1. This one I'm going to label it X1, X1, Y1. This is a new reference line and it's always drawn at 90 degrees to the lines of projection. These are the projection lines. So I am about to identify and locate the point C2. We will need C2, which is the image of C1. And for us to locate C2, we need to go back to the previous. We need to move backwards from C1 back to the elevation. And from there we capture or locate, collect this height, the C from XY, then bring it to the new XY. We are going to bring this distance to the new XY and mark that point. That point becomes C2. That's our new position, C2. What we need now is D. We need to locate D2. We do the same from D1, we move backwards towards D, collect that short distance, bring it to the new XY, and locate and mark. This is going to be my D2. So I've got C2, D2, of which the two must be connected. So I'm going to connect the 2 points. This gives me a line which is quite long, longer than these other images. This line is the true length, TL. That's the true length of CD. But let's not forget that we still have A1, B1. It also needs to be projected to the new auxiliary view. So I have to come back to A1, then go backwards to the elevation, collect that distance. Then I have to follow the A1 line, get that distance, mark it. So I'll mark it on the new auxiliary. This gives me A2. That is the image of A1. Right, I also still need the point B. It needs to be located on the new auxiliary. So I do the same from B1, go back, collect this short distance, take it along the B line from the XY. I will locate this point. This becomes our B2. We also need to connect the 2 points to give us the full line. So I will connect these 2 points and I get the line AB. As you can see, we have got CD, which is in its natural length, the true length, and AB, this line, which is not in its true length. So what we now need to do is to project another auxiliary view along the end of the true length line, which means the auxiliary view can be taken either from the right hand side towards the left, or you can take it from the left hand side. Whichever way, whichever direction you take will not affect our answer, our solution. So what we need now, I'm going to take an end-on view. I'm going to take an end-on view from this side, from the right-hand side. I'm going to take an end-on view from here, from the right-hand side. We'll put an arrow to indicate the direction of view. This is the direction of our next auxiliary view, which is taken along CD from the right-hand side. So what I need to do now is to place projection lines. I need to put projection lines along CD. So I will put my first projection line along CD, so which means it has to move like this to the left, to the left-hand side, along CD, and all the other lines have to follow in that direction. I have to make sure all the other lines follow, including the point A. This point is also going to be projected to the right, to the left-hand side. Right, we are projecting these two lines on the first auxiliary. The two lines on the first auxiliary. We need to project another line also passing through point B. This is going to be parallel, passing through point B like this. It's another line from B, from your point B, parallel. These are parallel lines. So if you look carefully, we are now having another set of projection lines that are heading towards the left-hand side. And the whole idea is to locate the points. We need to locate all the points. Right, we should worry more about CD first. We want to see what happens to CD. We need to locate our C to get C3, which will be on the far left. Right, how do we locate our C? If we look at our C, this C, we have to come back. We have to move back, cross the previous XY line, then we collect this distance. This distance is now going to be taken over to the new XY, but we need to place a new XY. We need to place a new XY plane so that we can transfer those distances. Right, how do we place our new XY? We place it at 90 degrees. It's always at 90 degrees to the lines of projection. At any point of convenience, I can place my XY here. This is going to be my X2, Y2. And these are at 90 degrees. So this is going to be my reference, new reference line. So for me to collect C2, I'll come back to C2 here, move backwards, collect this distance. That's the distance I need now. And I need to take this distance to the new X2, Y2. So I need to take it to X2, Y2, which is shown here. So I need that distance taken to x2, y2 along the C2 line. So if you look at the distances, they have to be taken now from that xy line, the x1, y1, x1, x2, y2. So that distance will be brought to the new xy. Then we mark. This is going to be C3. Now, if we go back to D2, and we try to look for D1 backwards, you will see that the distances are the same. We end up getting the same distances, which gives us D3. That's going to be our D3. We are having a case where D3C3 is a point. This is just one point. So the line has been reduced to a dot. It has been reduced to a point. Now, we still need to go back and locate the other points, the other line. The other line is A, B. We need AB. We need it on the new auxiliary. So for B, we move backwards, collect that distance for B. Then we bring it along the B line. Along the B line, we take that distance, which is a little bit shorter. This is B3. After collecting our B3, we need A. For A, if we go backwards, you see we are getting a long distance here. We get a long distance for A. That long distance has to be transferred now to the new xy, of which the distance is going to be located along this line. We are going to collect that distance. Remember, we need A. We need the position for A, which is taken along this. We come and mark it. We mark our point, which is further away from the xy. So that point, if you see it, this point becomes A3, of which if we connect the points to get our AB, we are going to have a line like this connecting B3 to A3. We are having a situation where we have a line and a point. That's the most crucial stage that we need to master or to reach. Now we've got a point here. We've got the line AB. This point is coming from the end on view. Right. We are looking for the shortest distance between a point and a straight line. Shortest distance, that distance is taken along a perpendicular. So the only way to get the shortest distance is to draw a perpendicular, a line which is at 90 degrees. This line is going to be at 90 degrees, drawn at 90 degrees to AB. So I'll draw a line here at 90 degrees. That line, this line is the shortest distance. This is our shortest distance between the skew lines. Right. In many cases, they will also ask you to find the projection of this shortest distance. on the given views, which means we would like to project that shortest distance back to the front and the plan. Now, the best way to project that shortest distance back to the original views is to identify the points where the shortest line meets the skew lines. In this case here, we can see that the shortest line obviously meets AB at this point. We can number it and call it point number 1. So far we know point number 1. Point number 2 is obviously on the dot. It's hidden on the point. So our point number 2 shares the same position with the C3D3. Now to trace backwards. What we need to do, we start with the distinct point here, point number 1, which is clearly visible. We have to take it back to the first auxiliary view. We take it backwards to the first. This was our first auxiliary view. This view is our first auxiliary. This is our first auxiliary view. So we need to take it back to our first auxiliary view. We need to take point number 1 back to our first auxiliary view. How do we do it? We project a parallel line. We project backwards a parallel line from point number 1 back to line AB on the first auxiliary. So we are going to project a parallel line, project it back from point number 1 back, then you stop at AB. When you stop at AB, you can see this line where it reaches AB. This is the point 1. Now we need to project it back again to its previous view. The previous view was the plan, and it must be located again on the same line, AB. So I'm going to project this one back until it meets line AB. So this point is taken back to this position. This is our point 1 again. I have to take it up to the elevation and to the same line, AB. So I'm projecting this one up. Then stop at the line AB. This gives us point 1. So far I've located point 1 backwards, the projections of point 1. I now need to go back to point number 2 and do the same. Point number 2 lies on CD, but we see that CD here, when you try to project it back, it goes back to the same line. Since this one is the true length, point number 2 should be located along a perpendicular. So I need to draw a perpendicular from point number 1 to line CD. A perpendicular, I will take a line which is at 90. This is very important. This position is very important. This line which is at 90 should be remembered. This is the most important line here on the construction. This one at 90. It gives us point number 2, which is at 90 degrees here. Once we have located point number 2, I now move backwards. You have to project it backwards to the plan so that we can locate that point number 2. Point number 2 is on on CD. So I have to take it back to CD. I have to project a line from point 2, then stop at CD. This is the point. This becomes our point 2. I have to take point 2 vertically up to the front with the parallel line until we reach point CD, line CD again. So I'm taking it up where it meets, the line meets CD. This is point 2. Once I've identified the projections, what is left is for me to connect those lines. Connect point number 1 to number 2. On each view, I'm now connecting the points. Right, if you look, these are the projections of the shortest distance. These are the projections of the shortest distance. Let me clearly mark them. This one is the projection on the plan and on the front. So far we have managed to find the shortest distance between skew lines and the projections of these of the shortest distance on the given views. This is what is required when you are looking for the shortest distance between skew lines. I hope you enjoyed the lecture. Thank you.